Make sure that you are not doing anything, but we're taking notes. That's it. Okay. So we're factoring when a is 1. So in our standard form quadratic, we have that ax squared plus bx plus c, right? And today we're focusing just on a equaling 1. Okay. And then when you come back on Monday, then we'll talk about when a is bigger than 1 and how we use factor by grouping to help us. Okay. So we're kind of taking a break from the factoring by grouping, and we'll come back to that on Monday. All right, but GCF, that's still going to come into play. So when a quadratic is written in standard form, okay, the a value is the coefficient of the first term. So that x squared. A is the coefficient of the first term. So again, to reiterate, what we do today on this first page only works when a is 1. Okay? So only if a is 1, we can use the following method to factor. First, we want to factor out a GCF, if there is one. So that's what we did yesterday, right? I'm sorry, Monday. We talked about, we first looked at when there's 2 terms, what was the GCF? We also even looked at when there's 3 terms. When your first term was negative, what did that tell you about your GCF?
Negative.
The GCF was negative, okay? So what we're going to be doing is we're going to find 2 numbers that are going to multiply to a times c. Okay, we get a times c from standard form. You just go a times c. We multiply those together. Now today, a is going to be 1, so just be 1 times c, right? We're going to find 2 numbers that multiply to a times c, which means they're factors, and they add to this b value here. Okay? 2 numbers that are going to multiply to a times c, and they add to the b value, the middle term. Okay? Once we find those 2 numbers, we're going to write 2 binomial factors. What is a binomial? How many terms does a binomial have? 2. Okay, so we're going to write 2 binomial factors, like x plus 2 times x plus 3. Okay? So we're going to write 2 binomial factors with the 2 numbers that you found. Okay? We do need to make sure that if there was a GCF that we factored out in the beginning, we still bring that down to the end, because otherwise it wouldn't be equivalent. All right? So once we actually do one of these, it'll make sense. This is a pretty easy process. Okay? So we have our first one here, 3x squared plus 24x plus 36. So first it says, check, is there a GCF? So what would the GCF be between 3, 24, and 36? 3. That's the largest number I can divide into all 3 terms. Do you agree with that?
Yes.
So GCF is 3. Okay? So that means I'm going to divide each of the 3 terms by 3. This is what we did yesterday. Now, GCFs do not disappear, right? We write those down with us. So 3 parentheses. So make sure you have all that written. And now we actually divide. So we have 3x squared divided by 3. What's that? 1x squared, right? 1x squared. Or you could have written that as just x squared. All right, the middle term, 24x divided by 3. What's that? Plus 8x. The last one, 36 divided by 3? 12. Okay? So that's not new. We did that yesterday, or Monday. I keep saying yesterday. I also did it yesterday, but you didn't do it yesterday. Okay? So now, once we find our GCF, we need to find what a times c is. Okay? So when I do a times c, I usually draw this little rainbow thing. I go a times c. What's 1 times 12?
12.
12. So I want you to write a 12 at the top of this little T-chart here. Okay? So I want to find 2 numbers that are going to multiply to 12, but I need them to add together to the b value. What's the b value in this expression?
8.
8. Okay? So numbers that multiply to 12 are just factors. So I could do, 1 times 12 is 12, right? What's 1 plus 12?
13.
13. Is that what I'm looking for?
No.
No, so these are not the factors I want. Okay, what's another factor of 12?
2 times 6.
2 times 6. 2 times 6 is 12. What's 2 plus 6? 8. Is that my b value?
No.
Ooh,
But yes.
yes. We all see that? Okay, so I want you to circle 2 and 6. Those are the two numbers we needed to find that multiply to a times c, but add to b. Okay, so once we find those, now we're just going to write out two binomial factors with them. Okay, so I'm going to have parentheses x, and then that's a positive 2, right? So I'm going to write plus 2 close parentheses. That's my first factor. Okay. Then I'm going to write the next factor right next to it because I'm multiplying it. And it's going to be x. I always start with the x. And then that's another positive 6. So plus 6 close parentheses. Okay. Now, the one thing I do have to bring down is that GCF. And this right here is my final answer. Oops. So it's as simple as that. I got two factors and then that GCF in the front. And that's my answer. If I were to multiply all this back out and simplify, I would get back to the original. Okay? So it's kind of like this, you think of it as like a little puzzle. Once you find those two numbers, you're golden. You find your answer. Okay? You ready for the next one? So this next one, a squared minus 5a minus 14. So let's talk GCF. I have a squared minus, so that would be a 1, right? Minus 5a minus 14. What's the greatest common factor that can divide into all three terms?
1.
1. Okay? Now, when there's a 1, do you really need to divide by it?
No.
No, because that, I mean, you just get the same thing, right? So when your GCF is 1, you don't have to factor anything out. We go straight into the factoring this trinomial. Okay? Does that make sense? So now we do a times c. So what is a times c?
14.
What kind of 14? Negative 14. 1 times negative 14 is negative 14. Okay? So we look at factors of negative 14. Now we do need to be careful because this is a negative number. For a number to be negative, its factors, one of them has to be positive, one has to be negative. We have to have different signs. So if I did this, I could say 1 is a factor of 14. 1 times negative 14 is negative 14, right? What is 1 plus negative 14? Careful. Negative 13. Is that what you said? I don't know if that's what someone said. So when you add a negative, same thing as subtracting, right? 1 minus 14. Okay, so that's not my b value, is it? No, so this is not my answer. So your next one, 2 and negative 7. 2 times negative 7 is negative 14. So always double check that you have the correct sign and correct factors. Then when you add them together, what do you get? Negative 5. Is that my b value? Yes. So that means my factors I want to use are these two, 2 and negative 7. Okay, so we set up our two binomial factors. In parentheses, I start with an x. So if my first factor is 2, what do I write after the x? Plus 2. Close parentheses. Then we open up a second set of parentheses, and what do you think is going to be in this next set?
X.
X what? Yeah, minus 7. So I use that factor there, minus 7. And there's no GCF, so size 1. That's my answer. See how this can go kind of quick? So the biggest thing is, can you find factors of a number? Now, if you have a larger number, you could be using Desmos, but I think most of the ones we have today are pretty small numbers. All right, let's look at the next one. We have x squared plus 5x plus 6. So for this one, what is the GCF? 1. So again, when it's 1, do I have to divide anything out?
No.
No. So let's do a times c. 1 times 6 is 6. So what are factors of 6?
1 and 6.
1 and 6. 1 times 6 is 6. What's 1 plus 6?
7.
Is that what I'm looking for?
No.
Do we all see that?
Yes.
Oh, I needed to add to this b value. Okay? So the only other two factors we have are 2 times 3. 2 times 3 is 6. What's 2 plus 3?
5.
Does that make sense?
Mm-hmm.
So these are my factors. So I want you to see if you can write out the factored form. Write out your two binomial factors. All right. So what did you get as your two factors?
X plus 2.
Okay. Can I hear from someone else? What's the other one? Times x plus 3. Yeah. All right. Is this pretty simple? You feel good about it so far?
Yes.
All right. So next one, 5n squared plus. Oh, you know what I did? I probably should have put an a with those because we had a's here. Sorry. That's a plus 2 times a minus 7. I mean, they're both letters, but variables. But to keep them consistent, sorry. All right, so our next one, 5n squared plus 15n minus 50. So what is my first step here?
GCF.
The GCF. So I need to find what is the GCF here. Yeah, the biggest number. And now remember, you could in Desmos do GCF parentheses 5, 15, 50. Okay, so, and we know the first term's positive, so my GCF is positive. So I divide by 5. When I do that, 5n squared divided by 5 is just n squared. 15 divided by 5 is plus 3, and I put the n there. Negative 50 divided by 5, that's negative 10. And now, because I could factor out that GCF, I have an a value of what? A. What's the a value? What's in front of n squared?
1.
1. So now, inside these parentheses, I have an a value of 1, a c value of negative 10. So I multiply 1 times negative 10 is negative 10. Okay? Now, when I look for my factors of negative 10, they have to add to what? 3. So when I do this, I can go, well, 1 times negative 10 is negative 10, right? They have to have different signs. 1 times negative 10 is negative 10. When I add those together, 1 plus negative 10, that's negative 9. Is that what I'm looking for? No. Okay? So then I can do 2 times negative 5 is negative 10. What's 2 plus negative 5? Negative 3. So here's the deal. when you get two numbers like this, and they give you the correct like number for B, but the wrong sign, here's what we can do. Isn't it true that -2 times +5 is still -10? What's -2 plus 5?
Positive 3.
It's +3. So all you need to do here is, if you have the right number but wrong sign, change the sign of both factors. Okay, and that goes for if they're both positive and you have the wrong sign, change both to negative. In this case, one was positive, one was negative. You flip both, so now we have a negative times a positive. Okay, because they still are two numbers that multiply to -10. But this time they add to +3. So these are my factors, or part of my factors. Okay, so when we write out our final answer, we're going to have in parentheses n minus 2. And then what would the second one be?
N plus 5.
N plus 5. Okay, what am I forgetting? Yeah, this 5 that GCF always bring down. Okay? Any questions?
No.
All right, so 4x squared minus 24x minus 20. So we first need to find that GCF. In this case, it would be a 4. I can divide a 4 out of all three terms. So I'm going to divide by 4 on all three terms. And I bring down the 4 in parentheses. Oops. Okay. So when I do this, 4x squared divided by 4 is just x squared. Negative 24x divided by 4 is negative 6x. 20 divided by 4 is positive 5. So now we multiply a times c and find some factors that add to b. So a times c would be positive 5. Positive 5 is prime, so there's only two factors of 5, right? 1 and 5. So 1 times 5 is 5. 1 plus 5 is 6. So again, we have right number, but wrong sign. Yeah? So what should I do? Yeah, make these both negative. Do -1 and -5. Two negatives multiplied together still give you a positive, right? But -1 plus -5 is equal to -6. So these are my two factors. So when I write this, I would have x, and that would be -1 times x minus 5. And I bring a 4 out front. All right, ready for the last one on this page?
Yes.
So we have m squared minus 2m minus 8. GCF of what? 1. So I can go straight into finding a times c. A times c is 1 times -8, which is -8. And then we look for factors. So 1 times -8 is -8. 1 plus -8 is -7. Is that the b value I'm looking for?
No.
No. Okay. So now I can do 2 times -4. 2 times -4 is -8. What's 2 plus -4? -2. These are what I'm looking for. So when I write out my answer, I have m plus 2 times m minus 4. And that's it. Okay? So if you're good with that, will you flip your paper over? This next thing is actually kind of a special case, called the difference of squares, okay? A difference of squares is exactly what it sounds like. We're subtracting something and they're squares. They're perfect squares. So when I say perfect squares, that means like 1 squared is equal to 1. So 1 is a perfect square because the square root of 1 is 1. 2 squared is 4. 4 is a perfect square because the square root of 4 goes back to 2, right? Do we know this kind of terminology? 3 squared is 9, so 9 is a perfect square. I'm just going to write out some of these. 4 squared is 16, so 16 is a perfect square. Oops. Let's see, we know, what's 5 squared? 25. What's 6 squared? 36. 7 squared? 49. Do one more. 8 squared? 64. Wow. Okay? So, what I have boxes around, squares around, get it, huh? Those are my perfect squares. Okay? So, when you know to use this when they follow these rules, okay? We're going to use our difference of squares rule when first it's a binomial, meaning there's 2 terms, right? Both terms need to be a perfect square. Say it again. Which means they can square root evenly. I can take its square root evenly. Okay? And then there must be a minus sign. It's called the difference. It's not called the sum. It's called the difference of squares. Okay? So how we do this is first factor out that GCF. Now, that's what we always do. We always check, is there a GCF to factor out? That's what we do on the front page as well. Then what we want to do is we're going to take both terms and take their square roots. And then we're going to write these 2 factors. And it's going to follow this right here. Okay, so a squared minus b squared. I take the square root of a squared, that's a. Take the square root of b squared, that's b. I set it up like this. The 2 things I find, you're going to set it up as a plus b times a minus b. So you add them together, multiply it, subtract them together. Subtract them. Okay, so let's look at our first example. Once we kind of do one, it makes a little bit more sense. So 4x squared minus 16. First check, is there a GCF? 4. I can take a 4 out, right? So I'm going to divide both terms by 4. So that's 4 parentheses. 4x squared divided by 4 is just x squared. Negative 16 divided by 4, what is that? Negative 4, okay? So now we check. We have a binomial, right? We have 2 terms. We're subtracting, it's a difference. X squared is a perfect square, because the square root of x squared is just x. Is 4 a perfect square? Yes, because the square root of 4 is 2. So what we do is we take each of these terms and we take its square root. So the square root of x squared is x, right? So I want you to circle what we find. After we take a square root, let's circle it. Okay? Then we take the square root of the next term, and we're ignoring the minus sign. So the square root of 4, what's the square root of 4? 2. So I'm going to circle that. So these right here are the 2 terms I'm going to use to put into this form here. A plus b times a minus b. So we're basically going to have 2 sets of parentheses. One where we're adding, one where we're subtracting. Okay? And in each of them, I take what I found the square root of. So the first one will be x plus 2 times x minus 2. And that's it. So difference of squares, eventually, you won't need to do this step. You'll just be able to see, oh, x squared minus 4, that's x plus 2 times x minus 2. X squared minus 25, x plus 5 times x minus 5. Okay, so that's where we're trying to get to. All right, let's look at our next one. Does that make sense? Any questions on that? All right, the next one, can we take a GCF of 2x squared minus 18? 2, yeah. So I'm going to divide this by 2. Oh, you know what I forgot down here? What did I forget? The 4. Whoops, squeeze that in there. Sorry. All right, so I divide these by 2, and I get 2x squared divided by 2 is x squared. And then 18 divided by 2, negative 18 divided by 2 is negative 9. Okay? Would you say this is a difference of squares? It's subtracting. X squared is a perfect square. 9 is a perfect square, right? So we take the square roots. What's the square root of x squared? X. So that's one of the terms in our factors. Then I do the square root of 9. What's the square root of 9? 3. Okay? So we take these two. We add them together, then we subtract them, right? So I'm going to have x plus 3 times what would be the second set?
X minus 2.
X minus 3. And we need to bring down that GCF of 2. Okay? All right, let's look at the next one. 49x squared minus 1. Is there a GCF? Yeah, it's just 1. So if it's just a 1, do I need to factor out a 1? No. Okay, so this time I'm looking at 49x squared minus 1. It's a difference. Is 49 a perfect square?
Yeah.
X squared is a perfect square. Is 1 a perfect square? Yes. Square root of 1 is 1, right? So I take this first one, the square root of 49x squared. When there's a coefficient there, just do it separately. What's the square root of 49? 7. And the square root of x squared? X. So it's just 7x. Does that make sense? Okay. Then we do the next one. What's the square root of 1? 1. So now I take these two terms. I put them in factors that are multiplying. You add them and you subtract them. So see if you can write out your final answer. What's the first factor? 7x plus 1. What's the second one? 7x minus 1. And there's no GCF we have to put out front, so that's our answer. Okay? So far so good?
Mm-hmm.
This is just one of those special cases that if you can know this trick, it makes things a lot easier in the long run. Okay? Let's look at our last one. Can I do the last one now?
Yes.
Moving this over. All right, 3x squared plus 27. What is my GCF? 3. So I'm going to divide a 3 out. When you divide a 3, what's left inside?
1x squared.
X squared, then what? That's 9, okay? Is x squared a perfect square? Is 9 a perfect square? Is this a difference? No. So this is not a difference of squares. Done. So, not a difference of squares. Not a difference of squares. So we can't do that trick. Now, if I gave you something like this, x squared minus 16, do you think you could factor that without showing anything? What would it be? It's a difference of squares. There's no GCF. What do you think it'd be? X plus 4, x minus 4. Yeah. Square root of x squared is x, square root of 16 is 4. Just take those two, add them together, and subtract them. So it gets quicker the more you do it. Okay? Any questions on this?